Welcome to another session of Everyday Mathematics. Here at Everyday Mathematics, as we always say, we do enjoy solving the harder problems, but above all, we do see and appreciate the beauty of the simpler problems. So today our problem comes from MIT 2022 Integration B Semifinal number 1, problem number 1. And this is from the topic of exponents. The problem is the integral or from x equals to 0 to x equals to infinity of x times into bracket e to the power negative x plus 1 over into bracket e to the power x minus 1. So this is a very interesting problem. But before we jump into the solution, I'd like to shout out to our subscribers. Thank you so much for your support. We don't take your support for granted. For our first-time visitors, a quick word to you is that here at Everyday Mathematics, what we do is we look around for these harder problems and we try and share the solutions that we think would be interesting to you. And then to our repeating visitors who haven't subscribed, what we can only say is we would really appreciate your support. So if you can and you're interested, please pause the video and to subscribe to our channel. That support will actually help us get the extra visibility that we need to keep this work going. So quickly into the solution. So what I would personally do when faced with this problem is I would like to harmonize the exponents, make either both negative or positive. So I chose to make both of them positive. And how I went about doing that is by separating the numerator and the denominator as regards this exponential function. So the e to the power negative x part is the same as 1 over e to the power x plus then 1 times its component, which is now 1 over e to the power x minus 1. So this can be reorganized into e to the power x plus 1 over e to the power x. That now means that now if we multiply these two terms together, we have e to the power x plus 1 over e to the power x times e to the power x minus 1. And so looking at the denominator alone, so separating them out, we have this expression. And then the next thing is we would like to use partial fractions to separate these denominators. So this third term here is the same as 1 over e to the power x minus 1 minus 1 over e to the power x. So if we multiply the e to the power x plus 1 term across, this is what we get. And if you look at this last time here, you divide this by this, you get 1, and then you're left with e to the power negative x. So now our main focus now will shift to this part here. And what I chose to do was to use long division to try and simplify that fraction. So if we have e to the power x plus 1, then you divide by e to the power x minus 1. You multiply this divisor by 1, you get e to the power x minus 1. So you subtract e to the power x minus 1 from e to the power x plus 1, you get positive 2. So that means that e to the power x plus 1 over e to the power x minus 1 is the same as 1 plus this remainder 2 over e to the power x minus 1. So fixing this back into the equation, that results into x into bracket 1 plus 2 to the power 2 over e to the power x minus 1 minus 1 plus e to the power x. So these ones cancel. And so we are left with an expression that now has only 2 over e to the power x minus 1 minus the power negative x in bracket here and multiply with x. So we have now 2x over e to the power x minus 1 minus x times e to the power negative x. So we can now separate this into two different integrals. We have the blue integral and then we have the green integral. So if we focus on the blue integral first, 2 times the integral of 2x over e to the power x minus 1 from 0 to infinity, the same as 2 times the integral. If we divide by e to the power x across, this is same as now x times e to the power negative x over 1 minus e to the power x. So if we focus on this last part, this looks like a summation of from k equals to 1 to infinity of a geometric progression of a constant ratio e to the power negative x. So we can plug that in. So we have x times the summation of k of from k equals to 1 to infinity of e to the power negative kx, right? So we can now move forward. What we can do is we can take this x into the summation sign, and so that won't affect the summation and also the integral because the index is not associated to it. Then now we can flip the summation and the integral sign. It doesn't affect since what we're just trying to do here is we could integrate. In other words, the way you could look at it is the integral of a sum is the same as the sum of the integrals. So it's just intuitive that way. So we're integrating each term. So here we're having the sum from k equals to 1 to infinity of the integral from 0 to infinity of kx times e to the power negative kx. So we can use integration by parts, which tells us that if you have a product of u and dv, the integration of that is the same as uv minus the integral of v du. And so if we take u to be x, and then we take, sorry, here this is dv to be equal to, let me write that out so that nobody mistakes it later. So this is dv, okay? If dv is e to the power negative kx, then du is equals to 1, and v is equals to negative 1 over k times e to the power negative kx. Therefore, this integral here is equal to twice the summation from k equals to 1 to infinity of, we have negative x, which is u. So we have negative x over k times e to the power negative kx with the limits applied appropriately, plus now our du is 1, so the x disappears, and then v is the same as negative 1 over k times e to the power kx, so the negative and the minus here means that this becomes positive, so we have the constant 1 over k brought out, and so we're left with the integration of e to the power negative kx from x equals to 0 to infinity. Now we'll apply the limits accordingly to this already integrated part. And what we come to realize is that that initial part with the limit as the upper limit, as limit tends as x tends to infinity of negative x over k times e to the power kx, since this term here tends to 0, it means 0 times some value here, this entire term goes to 0. And then here, since x tends to 0, 0 times some other term here, to be precise, 1 over k, this means that the entire term here goes to 0. So we are left with twice the integral, the summation of from k equals to 1 to infinity of 1 over k times the integral from 0 to infinity of e to the power minus kx. Now, this integral, obviously, when you integrate that, the same as negative 1 over k times e to the power negative kx, obviously with the limits applied appropriately. Now, when we apply the limits, when x tends to infinity, this exponential part goes to 0, so everything equals 0. And then when x tends to 0, this exponential part tends to 1, and so we're left with negative 1 over k, and then times this minus sign, so it becomes positive. So essentially, our blue integral results into 1 over k times 1 over k, which is equals to 2 times the summation of 1 over x squared. For those of you who know this, this is the same as the Bezier problem. And so the summation of 1 over k squared from k equals to 1 to infinity is the same as pi squared over 6. Now we multiply by 2. That means that now the blue integral results into pi squared over 3. Now, moving on to the green integral, the integral of x times e to the power minus x from 0 to infinity, using the integration by parts, if we take x to be, we would take u to be x and then dv to be negative e to the power negative x. So that initial part uv is shown here with the appropriate limits, and then v du is the same as e to the power negative x. So when we apply the limits appropriately, when x tends to infinity, e to the power negative x tends to 0, and when x tends to 0, x times e to the power negative x tends to 0, and so we're left with only the integral of e to the power negative x from 0 to infinity. So that means that we have this final integral, and then when we apply the limits accordingly, it means that as x tends to infinity, the e to the power negative x term tends to 0, and then when x tends to 0, e to the power negative x tends to 1, and so negative there means we have negative 1 times the minus there, it becomes 1. So our green integral is equal to 1. And so what we can do next now is when we look at the integral in totality, the integral of x times e to the power negative x plus 1 over e to the power x minus 1 is the same as the twice the blue integral minus the green integral. So twice the blue integral, as we saw, was pi squared over 3, and then the green integral was 1. So we have pi squared over 3 minus 1, and that is our final answer. So thank you so much. It was really fun hanging out with you. But as we saw, our final answer is pi squared over 3 minus 1. So thank you. Until next time, if you've not subscribed to our channel, please do consider subscribing to our channel. And yeah, keep following us. Thank you.